There are several ways of using hempcrete within the structure of a building, but its standard use is the construction of monolithic walls to form the thermal envelope. Hempcrete walls are not strong enough to be load-bearing, so the hempcrete is cast around a structural frame. The usual method is to build a simple studwork frame encased centrally within the cast hempcrete. All fixings must be alkaline resistant as they need to resist corrosion by the lime binder. A foundation exists for transferring the load of a building safely to stable ground. Unfortunately, hempcrete cannot be used as the foundation for a structure because the mixture can biodegrade if exposed to excessive moisture for long periods of time. Temporary shuttering is erected to create the mold for internal and external faces of a hempcrete wall. Shuttering boards need to be stiff enough to hold their shape, yet light enough to handle easily in large sheets. There is no definitive rule about what type of board should be used, but it should be hard-wearing, cheap, lightweight, easy to mark and cut, and able to be recycled at the end of its use. Hempcrete is made from a very specific ratio of industrialized hemp hurd, a lime-based binder, and water. Personal protective equipment is extremely important when mixing hempcrete. You will get chemical burns from the lime binder. I decided to make test bricks before starting the real project. Mixing hempcrete is easy to get wrong if you are not practiced. In this case, I will be using a basic hempcrete recipe of 3:1.75. 3 parts hemp shiv to 1 part water to 0.75 parts lime-based binder. First, I added and thoroughly mixed the water to the hemp hurds so that the hemp can soak up the water before adding the lime-based binder. It is recommended to use a pre-manufactured, building-approved lime binder, but due to budget constraints, I will be making a homemade lime-based binder. I am using a ratio of 4:1:1 for my binder, 4 parts Type S hydrated lime to 1 part Portland cement and 1 part sand. When the lime binder is mixed, it is added to the damp hemp hurd and the chemical set begins. Once the hempcrete is properly mixed, it is placed into its sample form. It is very important that the hempcrete is pressed to fill all voids, paying attention to angles and corners. A tamping stick or gloved hand are the best options for properly executing this step. Typically, the forms for light and medium density hempcrete can be removed in about 30 minutes, and the exposed hempcrete will maintain its form. I wanted to play it safe, so allowed my test bricks to remain in their forms overnight before removing them. Results? Looks good. They were still holding their form after 2 weeks. Time to start work on the real thing. Now that my mixed proportions have been established, I use the same ratios on a larger scale. The 2 most common options for large-scale mixing of hempcrete is a horizontal shaft mortar mixer and a vertical shaft mixer. Because it was free to borrow, I used a barrel-style cement mixer. Not recommended. The lightweight hempcrete becomes glued to the sides of the barrel as soon as the water is introduced. I made it work, but the style mixer would be entirely inadequate for mixing large batch hempcrete. A mix of hempcrete will be workable for 30 to 90 minutes depending on the strength of the binder. Keep finished mixes covered and out of direct sunlight. Small buckets or shovels can be used to transfer the hempcrete to the forms. Spread the material out in the forms and build it up to a depth of 4 to 8 inches. Again, a gloved hand or a piece of wood that is long enough to reach the bottom of the form can be used to tamp or press the hempcrete to fill any voids. Repeat these steps until it bulges slightly beyond the top of the form. 29 batches of Hempcrete later, and the forms are filled. Again, the forms can be removed after about 30 minutes, but I allowed my Hempcrete to set in the forms for 12 hours. There are no negative structural repercussions in allowing the forms to stay attached longer, just time constraints. The longer the forms remain attached, the longer it will take the Hempcrete to dry. Try to remove the shuttering carefully as to avoid creating any imperfections in your Hempcrete wall. Whew, got lucky there. Once the forms are removed, the drying process can really begin. The binder usually achieves its initial set overnight, but hardening of the binder set continues over the next few weeks until it has achieved its maximum compression strength. It is important to note that this does not mean that the wall is completely dry. The moisture content in any natural breathable wall containing plant materials is never zero. In regard to Hempcrete, you can expect a natural resting moisture content of around 14 to 16%, but this varies depending on a number of factors including type of binder used, the thickness of the wall, local weather conditions, and mixing technique. After about 6 to 8 weeks, you can expect the walls to have a moisture content below 20%, low enough to apply your finish. Finishes applied to Hempcrete walls protect it from damage and prevent excessive moisture ingress. Because Hempcrete is vapor permeable, it is important the finish is also a breathable coating. Typically, a vapor permeable lime or clay plaster is used to coat the exterior walls. Unfortunately, I was not able to apply a finish to my structure due to time constraints of the project. Hempcrete walls form extremely durable structures that are fire, pest, and mold resistant. They have high thermal resistance, low air infiltration, and are recyclable. The list of human health and environmental benefits of this material are impressive and should be utilized. For more information on how to build with Hempcrete and all of its astonishing benefits, check out these amazing references. Thanks for watching!